there is a moon orbiting Jupiter that should not behave the way it does. Not according to our models, not according to our equations, not according to anything we thought we understood about how worlds work at the edge of the solar system. And yet, there it is. Europa, a world smaller than our own moon, locked in a gravitational embrace so violent, so relentless, that its interior never stops moving, never stops churning, never stops generating heat from nothing but the sheer mechanical brutality of Jupiter's pull. Beneath a surface of fractured ice, ancient, scarred, crossed by 1,000 cracks, like the skin of something that has been stretched and broken and stretched again, there is an ocean, a real ocean, not a metaphor, not a geological trace, not the ghost of water long evaporated into space. Liquid water. Right now, as you breathe, as your heart beats, as the seconds pass between one moment and the next, the ocean on Europa continues to move, continues to churn, continues to exist in total, absolute crushing darkness, more than 500 million miles from the sun. That alone should stop you. That alone should make you reconsider everything you think you know about where life is possible. But that is not the disturbing part. The disturbing part is what we found coming out of it. In 2012, instruments aboard the Hubble Space Telescope detected something rising from the southern pole of Europa. Not gas from a volcanic vent, not a simple atmospheric escape. Something was being ejected violently, repeatedly, in enormous plumes from beneath the ice. Water vapor, liquid particles, material from the interior of the moon, launched more than 100 miles into space above the surface. Europa was venting. Europa was exhaling. And when those plumes were analyzed, when the chemical composition of what had been violently expelled from the deep interior of this frozen world was examined, the results did not simplify the mystery. They deepened it. The compounds detected in those plumes were not the simple, inert signatures of geological activity. They carried complexity. They carried the kind of molecular architecture that, on this planet, we associate with one thing above all others: chemistry that feeds life, not life itself, not a signal, not a message, but the building blocks, the scaffolding, the raw ingredients laid out in a pattern that made the people studying those readings go very quiet for a very long time. Silence is not the natural state of a scientific team that has just confirmed a geological finding. Silence is what happens when a finding refuses to be simple. There is something else. Beneath the ice of Europa, the ocean floor is not cold and dead. The same tidal forces that heat the interior of the moon, the same gravitational violence that keeps the water liquid against all reason, in a place where sunlight is a faint, distant memory. Those same forces fracture the rocky mantle at the bottom of the ocean. Hydrothermal vents. On Earth, the deep ocean vents were once considered dead zones. Too dark, too pressurized, too far from sunlight, which we believed, for a long time with great confidence, was the non-negotiable foundation of all life. We were wrong. When the first deep-sea submersibles descended to those vents in the late 20th century, they did not find dead rock and sterile water. They found ecosystems, dense, thriving, impossible ecosystems, built not on sunlight, but on chemical energy, on the heat and the sulfur and the mineral richness pouring from cracks in the Earth's own skin. Life had found another way. Life does not need the sun. Life needs energy. Life needs liquid water. Life needs chemistry. Europa has all three, and it has had them continuously, without interruption, for potentially billions of years, longer than complex life has existed on Earth. Let that scale land fully before we continue. While the continents of this planet were still forming, while the atmosphere above you was still being assembled from volcanic outgassing and cometary bombardment, while the first fragile chains of self-replicating molecules were struggling to persist in the warm pools of a young Earth, Europa's ocean was already old, already dark, already deep, already moving. If life arose in that ocean even once, even in the most primitive, microscopic, chemically humble form imaginable, it would have had billions of years to do what life on Earth did. Adapt, persist, diversify. We have not confirmed life on Europa. That statement is important and must not be skipped over. But here is what must also be said, with equal weight and equal precision. We have not ruled it out. Not even close. Every model we have built, every simulation we have run, every comparison we have drawn to the extremophile ecosystems in the coldest and darkest places on this planet, all of it points toward Europa, not as an unlikely candidate, but as one of the most probable locations in the entire solar system where life, in some form, may exist right now. Not in the past, not in a distant future. Now, and the most disturbing element of this entire situation, the thing that should genuinely unsettle you as you consider it, is not the possibility of life. It is the silence. We have known about Europa's ocean for decades. We have watched the plumes. We have analyzed the chemistry. We have built the models, run the simulations, drawn the comparisons, and we have not gone back. Not with the instruments capable of answering the question that matters most. Not with the tools required to push through the ice and reach the water beneath. Not with the mission profile designed from the ground up to look, actually look, for what might be alive in that darkness. We have orbited. We have photographed. We have theorized. But we have not descended. And the question that hangs over everything that follows, the question that cannot be answered by any telescope or spectrometer currently pointed at Jupiter's system, is whether that delay is simply a matter of engineering and budget and orbital mechanics, or whether some part of us, some quiet and rarely acknowledged part of the scientific enterprise itself, is hesitating. Because to go there, truly go there, is to risk an answer. And the answer, in either direction, changes everything. If nothing lives in Europa's ocean, then the universe is a more barren and more indifferent place than our instincts have ever been willing to accept. If something does, then we have never been alone. And everything we thought we knew about our place in the cosmos dissolves quietly and permanently into the dark water of a moon we have been circling for 40 years without ever truly understanding. This is where we begin. To understand why Europa disturbs us so deeply, you must first understand what it costs a world to be alive. Not life in the biological sense, not yet, but alive in the geological sense, active, dynamic, internally energized. The way a planet must be to sustain the conditions that chemistry requires before it can even attempt the extraordinary leap towards self-replication. Most moons in the outer solar system are dead, frozen, silent, geologically inert objects drifting in the dark, their interiors long cooled, their surfaces unchanged for billions of years. Monuments to entropy. Reminders that the universe's default state is not complexity, it is stillness. Europa should be one of them. By every reasonable calculation, by every thermal model applied to a body of its size and composition at its distance from the Sun. Europa should have exhausted its internal heat long ago. Its rocky core should have cooled. Its water should have frozen solid, not just at the surface, but all the way down, layer by layer, until the entire moon became a solid block of ice and silicate rock drifting silently around a gas giant that pays it no particular attention. That is not what happened. What happened instead is one of the most violent and intimate gravitational relationships in the known solar system. A relationship so extreme, so relentless, so physically transformative that it has kept an entire ocean liquid for billions of years without a single ray of direct sunlight ever reaching it. Jupiter is not simply large. Jupiter is a gravitational tyrant. Its mass is greater than all other planets in this solar system combined. More than twice the mass of Saturn, Uranus, and Neptune added together, with room left over. When Europa orbits this monster at a distance of roughly 670,000 kilometers, it does not orbit in a perfect circle. The gravitational influence of the other Galilean moons, Io, Ganymede, Callisto, pushes and pulls at Europa's path, stretching its orbit into a slight but critical ellipse. And that ellipse changes everything. As Europa moves closer to Jupiter during its orbit, the gravitational pull intensifies. The moon is physically squeezed, compressed, like a rubber ball held in a tightening fist. As it moves farther away, that pull relaxes. The moon expands back. This cycle, compression and release, happens continuously, once every 3.5 Earth days, without pause, without mercy, without end. This is tidal flexing, and the friction generated by this constant deformation does not disappear. Friction cannot disappear. The first law of thermodynamics does not negotiate. That mechanical energy must go somewhere, and where it goes is inward, transforming into heat, warming the rocky mantle and the boundary between rock and water, keeping the interior of Europa perpetually, impossibly warm. Jupiter is, in the most literal physical sense, squeezing heat into this moon, like a hand wringing water from a cloth. Think about what that means philosophically for a moment. Europa does not orbit the sun for warmth. Europa does not rely on any star for the energy that sustains its interior. It is heated by gravity itself, by the pure mechanical consequence of mass attracting mass, a process that requires no fuel, no combustion, no nuclear reaction. Just position, just relationship. Just the unavoidable consequence of existing in proximity to something overwhelmingly large, in a universe that will one day be cold and dark. When every star has burned out, when every black hole has evaporated through Hawking radiation into the final diffuse warmth of a universe approaching maximum entropy, tidal heating will be one of the last energy sources standing. Moons locked in resonant orbits around massive planets could theoretically maintain liquid water oceans for trillions of years after the last sun goes dark. Europa is not just an ocean world. Europa is a preview of what life's last refugees might look like at the end of time itself. But let us return to the structure of the moon, because the architecture of Europa is not simply interesting. It is, in the most precise scientific sense, suspicious. The surface ice is not uniform. It is fractured into vast plates, enormous slabs hundreds of kilometers across, that have shifted, rotated, and ground against each other in patterns that geologists call chaos terrain. These regions look from orbit like the surface of a frozen sea that has been broken apart and refrozen at slightly wrong angles. Like ice flows photographed from an airplane on an Arctic morning, except each flow is the size of a continent. This is not random damage from meteor impacts. This is evidence of motion from below. The ice is moving because the ocean beneath it is moving. Convection currents in the liquid water, driven by the heat rising from the rocky floor, push against the underside of the ice shell, none of the way the weather systems of a planet push against its atmosphere. Slowly, continuously, irresistibly, the ice of Europa breathes. And here is where the architecture becomes genuinely alarming. Not in a dramatic sense, but in the quiet, precise way that unexpected data alarms a careful scientist sitting in a room full of numbers that don't add up the way they should. The ice shell of Europa is estimated to be between 15 and 25 kilometers thick in most regions. Below that, the ocean. Estimated depth, between 60 and 150 kilometers of liquid salt water. For context, the deepest point in Earth's oceans, the Challenger Deep in the Mariana Trench, sits at just under 11 kilometers below the surface. Europa's ocean is not comparable to Earth's oceans. Europa's ocean dwarfs them. The total volume of liquid water contained beneath the ice of this small frozen moon is estimated to be more than twice the total volume of all of Earth's oceans combined. Every river, every lake, every sea, every drop of liquid water on the surface of this planet, doubled and then sealed beneath 20 kilometers of ancient ice in the darkness of the outer solar system. There is more liquid water on Europa than on Earth. Read that again. Let it recalibrate your sense of where the water in this solar system actually lives. We call Earth the blue planet. We call it the ocean world. We use our seas as the defining visual feature of this place when seen from space. That unmistakable blue marble, the water-rich anomaly in a dry and rocky solar system. But Europa makes Earth's oceans look like a puddle. And this ocean, this vast, ancient, pressurized, chemically active body of water sitting on top of a hydrothermally active rocky floor, has been there, in some form, for potentially 4 billion years. 4 billion years is a number that resists full comprehension. It is not a long time in the way that a century is a long time, or a millennium, or even a million years. 4 billion years is a duration so vast that it swallows the entire history of complex life on Earth without difficulty, and still has time left over. The first animals on Earth appeared approximately 600 million years ago. The first vertebrates, creatures with spines, the ancestors of every fish and amphibian and reptile and mammal and human being that has ever existed, appeared roughly 500 million years ago. Europa's ocean was already 3.5 billion years old by then. Whatever process might unfold in that water, whatever chemistry, whatever reaction, whatever improbable cascade of molecular events might lead from simple compounds to self-replicating structures, it has had time. More time than life on Earth needed to go from single-celled organisms to the beings capable of building telescopes and pointing them at the sky and asking, with genuine uncertainty, whether they are alone. That is the weight of this moon, not its mass, not its orbital mechanics, not even its extraordinary internal ocean. Its weight is time. The time it has had. The time it has spent in darkness, in pressure, in chemical richness, in silence. Doing something or doing nothing, and us not yet knowing which. That uncertainty, that specific, scientifically grounded, physically justified uncertainty, is the most profound open question in planetary science today. And we are only beginning to understand what it truly asks of us. The plumes changed everything, not metaphorically, not as a rhetorical device to structure a narrative. Literally, the detection of water vapor erupting from the surface of Europa restructured the scientific conversation about this moon in a way that no orbital photograph or spectral analysis had managed to do in the decades prior. Before the plumes, Europa was a promise, a beautiful, theoretically compelling, mathematically supported promise. But a promise nonetheless. The ocean was inferred. The tidal heating was calculated. The hydrothermal activity was modeled. Everything pointed in the same direction. But everything was also, technically, a sophisticated extrapolation from surface data and gravitational measurements. The ocean had never been directly sampled. The interior had never been directly observed. The case for Europa as a habitable world was built on extraordinarily solid reasoning. But it was still reasoning, not contact. Then Hubble looked south, and something was coming out. The plumes detected above Europa's southern polar region reach heights of more than 200 kilometers above the surface. 200 kilometers. To put that in terrestrial terms, the International Space Station orbits Earth at approximately 400 kilometers altitude. These eruptions from Europa's interior rise halfway to where our astronauts sleep and work in low Earth orbit. This is not a gentle seep of gas from a surface crack. This is a violent, pressurized expulsion of material from deep within the moon, driven upward through the ice shell by forces that originate at the ocean floor, travel through kilometers of liquid water, penetrate the ice, and erupt into the vacuum of space with enough energy to send particles hundreds of kilometers into the sky before they fall back to the surface as frost. Europa sneezes, and the sneeze reaches the edge of space. The implications of this are almost impossible to overstate from a scientific perspective, because what it means is that the interior of Europa is not sealed, not isolated, not permanently locked away behind 20 kilometers of impenetrable ice, requiring a nuclear-powered drill and a decade of engineering to access. The interior is communicating with the exterior, material from the ocean, chemistry from the deep, compounds from the hydrothermal environment, particles that have been in contact with the rocky floor of an alien sea, is being delivered directly into space, where an orbiting spacecraft with the right instruments can collect it, analyze it, and read it like a message written in molecular structure. Europa is offering us its ocean, not all of it. Not a sample return in any controlled scientific sense, but a continuous, natural, gravitationally driven delivery of interior material into accessible space, a phenomenon that, had it not been discovered, would have made the scientific case for a lander or a subsurface probe the only viable path to understanding what lives, or does not live, in that water. Instead, we may be able to fly through the exhalation of an alien ocean and read its chemistry from orbit. The Galileo spacecraft, which spent 8 years orbiting Jupiter between 1995 and 2003, passed through what scientists now believe may have been an active plume without knowing it at the time. The data from that flyby was reanalyzed years later, after the plumes were confirmed by Hubble. And the signatures were there, buried in the magnetometer and plasma readings, quiet and overlooked for more than a decade. Europa was exhaling while we flew through its breath, and we did not recognize it. There is something philosophically devastating about that realization. The evidence was in our instruments. The data was in our databases. The answer, or the edge of the answer, was sitting in archived files, while the scientific community spent years debating whether an ocean even existed beneath the ice. We had already passed through the proof. We had already collected it. We simply did not yet have the context to understand what we were holding. This is not a failure of intelligence or diligence. It is a reminder of how science actually works. Not as a clean, linear progression from ignorance to understanding, but as a recursive, non-linear process of accumulation and reinterpretation, where answers are sometimes found not in new data, but in old data read with new eyes. The chemistry of those plumes deserves particular attention, because what has been identified in the material ejected from Europa's interior is not geologically simple. Sodium chloride, common salt, the same compound that makes Earth's oceans saline, has been detected on Europa's surface in concentrations and distributions consistent with an interior ocean that has been chemically interacting with rocky material for billions of years. Salt in an ocean requires dissolution. Dissolution requires liquid water in contact with mineral-rich rock over extended time periods. The salt on Europa's surface is not a surface phenomenon. It came from below. Hydrogen peroxide has also been identified on the ice, a compound formed when water ice is bombarded by the intense radiation environment around Jupiter. And here is where the chemistry becomes genuinely provocative. When hydrogen peroxide migrates from the irradiated surface into the warmer subsurface and eventually into the ocean, it acts as an oxidant, a chemical fuel source. On Earth, oxidants are fundamental to energy metabolism. The oxygen you breathe right now is an oxidant. It accepts electrons in the chemical reactions that power every cell in your body. Remove the oxidant, and the reaction stops. Remove the reaction, and the cell dies. Europa may be delivering oxidants from its surface into its ocean through the same tidal and geological processes that drive everything else on this moon. Slowly, continuously, over geological timescales, seeding the deep water with the chemical energy currency that life, as we understand it, requires to function. This is not speculation dressed in scientific language. This is a chemically coherent, thermodynamically consistent pathway. From radiation at the surface, to oxidant production in the ice, to delivery into the ocean, to potential support of metabolic processes at the hydrothermal vents on the ocean floor. Every link in that chain has a physical mechanism. Every step is governed by chemistry we understand and have tested in laboratory conditions on Earth. The pathway exists. Whether anything walks that pathway, whether any organism, any self-replicating molecular system, any form of life, however alien and however microscopic, actually uses this chemical infrastructure to persist in the darkness of Europa's ocean. That is the question that no amount of orbital observation can fully answer. But consider what it means that the question is even scientifically coherent. A generation ago, 2 generations ago, the idea that liquid water could exist beneath the ice of a moon orbiting Jupiter would have been considered romantically optimistic at best, scientifically irresponsible at worst. The consensus was clear. Life required proximity to a star. Life required sunlight. Life required the narrow, temperate surface conditions that only a planet in the habitable zone of a solar system could provide. Europa did not fit that model. Europa demolished it, and when the model was demolished, when the discovery of deep-sea hydrothermal ecosystems on Earth, combined with the evidence of Europa's subsurface ocean, forced a fundamental revision of what habitable actually means. The universe did not shrink. It expanded. Every icy moon with a subsurface ocean became a candidate. Enceladus at Saturn, actively venting water vapor confirmed to contain complex organic molecules and molecular hydrogen, a direct signature of hydrothermal activity. Titan, with its dense atmosphere and surface lakes of liquid methane, a solvent so alien to our chemistry that imagining life within it requires abandoning almost every biochemical assumption we carry. Ganymede, Callisto, possibly even Pluto, at the cold edge of the solar system, may harbor a liquid layer beneath its nitrogen ice. The solar system did not have one ocean world. The solar system is full of ocean worlds, and we spent centuries staring at them from a distance, building our models around the assumption that none of them mattered, because the sun did not reach them, and life, we were certain, followed the sun. Europa was the crack in that certainty. The plumes were the light coming through it, and what we glimpsed through that crack, what the chemistry of those ejected particles suggests about the nature of the environment producing them, is a world not barren and irrelevant, but active and ancient and chemically generous in ways that challenge the deepest assumptions about what the universe permits, about what the universe encourages, about whether life, in the end, is a fragile and improbable exception, or something far more stubborn, far more creative, and far more widespread than we have ever dared to believe. There is a number that haunts this entire conversation. Not a distance, not a temperature, not a measurement of pressure or salinity or orbital period, all of which are extraordinary in their own right, and all of which we have already examined with the precision they deserve. The number is 40. 40 years. That is approximately how long humanity has known, with genuine scientific confidence, that Europa harbors a subsurface liquid ocean. The Voyager flybys of 1979 provided the first detailed images of the fractured, chaotic surface. Images that made the geological case for a dynamic interior impossible to dismiss. The Galileo mission, arriving at Jupiter in 1995, confirmed the ocean through magnetometer readings that detected the electromagnetic signature of a conducting fluid beneath the ice. A signature that only liquid salt water could produce. 40 years of knowledge. 40 years of models refined and predictions validated, and scientific consensus hardened into near certainty. And in those 40 years, we have sent exactly 0 missions designed specifically to answer the question that matters most. 0. Not one lander, not one subsurface probe, not one mission profile built from the engineering foundation up with the singular, unambiguous objective of determining whether Europa's ocean contains life. This is the silence that science cannot fully explain. And it is worth sitting with that silence, not rushing past it toward the next data point or the next mission announcement, because the silence itself is data. The silence itself tells us something about how we, as a civilization, relate to the most profound question we have ever been positioned to answer. The engineering challenges are real. They must be acknowledged honestly and without minimization. Europa sits more than 500 million miles from Earth at its closest approach. A spacecraft traveling there requires years of transit time, precise gravitational assist maneuvers threading through the complex orbital mechanics of the Jovian system, and enough radiation shielding to survive the most intense particle bombardment in the solar system outside of the Sun itself. Jupiter's magnetosphere is not a passive environment. It is an accelerator. A vast, invisible machine that strips electrons from atoms and hurls them at velocities approaching a significant fraction of the speed of light. The radiation environment around Europa is so extreme that unshielded electronics would fail within hours. A human being standing on the surface of Europa without protection would receive a lethal radiation dose in less than a day. These are not trivial obstacles. They are the kind of obstacles that consume decades of engineering effort and billions of dollars of investment. And they explain, in part, why the cadence of exploration at Europa has been so much slower than the urgency of the scientific questions would seem to demand. But engineering difficulty does not fully account for the silence, because we have solved harder problems. We landed human beings on the moon using computers with less processing power than a modern digital wristwatch. We soft-landed a nuclear-powered rover the size of a small car on the surface of Mars using a sky crane system. A hover vehicle that lowered the rover on cables and then flew away to crash at a safe distance. A sequence of events so audacious that the engineering team called it 7 minutes of terror and genuinely did not know, in real time, whether it had worked until the signal arrived. We built a telescope, the James Webb Space Telescope, so precisely calibrated that its mirror segments must maintain alignment to within 1/50,000th the width of a human hair. And we deployed it 1,000,000 miles from Earth, unfolding it in space like an origami structure the size of a tennis court, and it worked. We are not a civilization that stops at hard. We are a civilization that builds the tools to solve hard, when the will to solve it is present, when the funding follows the will, and when the question being asked is considered urgent enough to justify the cost. And so the question becomes uncomfortable. Is the question of life on Europa not considered urgent enough? Or is there something else operating beneath the surface of the institutional decisions, something quieter and more difficult to name? A hesitation that lives not in the engineering departments or the budget committees, but in the more fundamental human relationship with the answer itself. Consider what confirmation of life on Europa would actually mean, not in the abstract philosophical sense that scientists use at press conferences when they say it would change everything, but in the concrete, structural, civilization-level sense of what it would require us to revise. Every major human religious tradition is built on some form of narrative about the relationship between life, consciousness, and the cosmos. Most of those narratives place humanity, or at minimum, Earth-based life, in a position of singular significance. Chosen, created, special, the intended recipients of a universe constructed with purpose and direction. The confirmation of life elsewhere, even microbial life, even organisms so simple they have no nervous system, no behavior, no awareness of their own existence, does not merely add a data point to the biological census of the solar system. It restructures the narrative. It transforms humanity from the protagonist of a story about life in the universe into a character in a story about life in the universe. And those are not the same story. This is not a theological argument. It is a psychological and sociological observation about how human civilizations process paradigm shifts. And the history of science is unambiguous on this point. When Copernicus proposed that the Earth moved around the sun rather than the reverse, the resistance was not primarily about astronomy. It was about the implications of astronomy, about what it meant for the human position in the cosmos if we were not at the center. The math was available. The observations supported the model. The resistance was existential. When Darwin proposed that species were not fixed and separately created, but related through common descent. The resistance was not primarily about biology. It was about what it meant for human dignity and human uniqueness if we shared ancestry with every other living thing on Earth. The scientific questions were answerable. The answers were correct, but the integration of those answers into the broader human self-understanding took generations. And in some communities, the resistance has never fully resolved. Now consider Europa. The question being posed above that frozen ocean is not whether the Earth moves or whether species share common ancestors. The question is whether we are alone, whether the emergence of life, of organized, self-replicating, chemically complex life, is a singular miracle that happened once on one planet by a chain of events so improbable they will never be repeated anywhere in the observable universe. Or whether life is what the universe does. Whether the same chemistry, the same thermodynamics, the same tidal forces and liquid water and mineral-rich ocean floors that produced everything alive on Earth are operating right now in the dark water beneath Europa's ice, producing something that replicates, something that metabolizes, something that has been there in the cold and the pressure and the chemical richness for longer than complex life has existed on this planet. The data does not yet answer this question, but the data no longer dismisses it. And that transition from dismissible speculation to scientifically coherent possibility is precisely where the silence becomes most difficult to explain. Because a scientifically coherent possibility, backed by 40 years of converging evidence and supported by every extremophile ecosystem we have ever discovered on Earth, is not a question that a civilization serious about understanding its place in the universe should be comfortable leaving unanswered. The Europa Clipper spacecraft, launched in October 2024, scheduled to arrive at Jupiter in 2030, will perform dozens of close flybys of Europa, analyzing the plumes, mapping the surface, probing the ice with radar, and building the most detailed picture of this moon ever assembled. It is an extraordinary mission. It is also not designed to answer the question of life directly. It is designed to assess habitability, to determine with greater precision whether the conditions for life are present, and to identify the best locations for a future lander mission that might one day actually reach the surface, drill through the ice, and sample the ocean below. It is a mission designed to plan for the mission that will answer the question. Which means the answer, the actual answer, is still decades away. 40 years of knowing, and the answer is still decades away. That gap between what we know and what we are willing to do with what we know is not an engineering problem. It is a mirror, and what it reflects about us is worth examining with the same rigor we apply to the data coming from 500 million miles away. Assume for a moment that the answer is yes. Not as a fantasy, not as a concession to optimism or a surrender to the romantic pull of the idea. Assume it as a scientific exercise. The kind of disciplined, structured speculation that physicists use when they say, imagine a universe where, and then follow the logic wherever it leads, regardless of comfort. Assume that in the ocean beneath Europa's ice, something lives. What is it? This is not a trivial question dressed in simple clothing. It is one of the most technically demanding and philosophically rich questions in all of contemporary science. Because the answer depends entirely on which of two radically different possibilities turns out to be true. And those two possibilities carry implications so divergent, so structurally different in what they mean for our understanding of life as a phenomenon, that choosing between them is not merely a matter of biological classification. It is a matter of cosmology. The first possibility is that life on Europa, if it exists, is related to life on Earth, not metaphorically related. Literally, physically, genetically related, descended from a common ancestor, sharing the same basic molecular machinery, built from the same left-handed amino acids and the same nucleotide bases that underlie every living thing on this planet. From the bacterium in your gut to the blue whale in the redwood tree and the tardigrade surviving in the vacuum of space, this is not as outlandish as it sounds. The solar system is not a sealed system of isolated worlds. It is a dynamic, violent, interconnected environment where material moves between planetary bodies with regularity. Every major impact event, every asteroid or comet strike powerful enough to excavate deep into a planet's crust, ejects material into space. Some of that material achieves escape velocity. Some of it drifts through the inner solar system for millions of years before being captured by the gravity of another body and falling to the surface. This process has a name: lithopanspermia. And it is not theoretical. It is documented. Meteorites of confirmed Martian origin have been found on Earth. The transit of rocky material between the inner planets is a physical reality, not a hypothesis. And if material can travel from Mars to Earth, it can travel, given enough time and the right trajectory, to the moons of Jupiter, or from them. If life arose on early Earth, or on early Mars, which may have been hospitable to life before Earth was, and if that life was simple enough and robust enough to survive the radiation exposure of interplanetary transit embedded in a rocky fragment, then the ocean of Europa may have been seeded from within our own solar system's biological history. In this scenario, life on Europa would be our cousin, distant beyond all measure of meaningful relationship, separated by billions of years of independent evolution in radically different environments, unrecognizable in form and behavior and metabolic strategy, but sharing, at the deepest molecular level, the same origin story, the same first chemistry, the same ancestral encoding system, the same fundamental decision that life on Earth made at its very beginning about how to store and transmit information. The discovery of life on Europa that shares this common molecular architecture would be extraordinary. It would also be, in a specific and important sense, the less disturbing outcome, because it would mean that life, once started, spreads. That the solar system is not a collection of isolated biological experiments, but a connected environment where life, given time and the mechanics of impact and transit, can move between worlds and establish itself wherever conditions permit. Profound, paradigm-shifting, civilization redefining, but still, in the deepest sense, familiar. The second possibility is the one that keeps certain scientists awake in a different way entirely. The second possibility is that life on Europa arose independently, that in the ocean beneath that frozen surface, the chemistry of self-replication was discovered, or stumbled upon, or inevitably reached by the thermodynamic logic of complex systems far from equilibrium. Not because a rocky fragment carrying Earth's biology fell from the sky, but because the conditions were right, and life is what happens when the conditions are right. A second genesis, life that did not inherit our molecular solutions, life that may not use DNA, life that may not use the same 20 amino acids, life that may have solved the problem of self-replication through a completely different chemical architecture, one that we do not yet know how to recognize, one for which our instruments were not designed, one that might sit in a sample return canister and be dismissed as interesting chemistry for years before someone thinks to ask whether the interesting chemistry is alive. The implications of a second genesis are not comparable to anything else in the history of science, because a second genesis does not just mean that life exists elsewhere. It means that life is convergent. It means that the universe, given liquid water and chemical energy and time, does not merely permit life. It produces it. reliably, perhaps inevitably. The way water reliably flows downhill, not because it chooses to, but because gravity is a consistent feature of physical reality, and water has no option but to respond to it. If life arose twice in a single solar system, on a planet and on one of that planet's neighbor's moons, independently, through different chemistry, reaching the same extraordinary conclusion of self-replication by different molecular paths, then the universe is not a place where life is a vanishingly improbable accident. The universe is a place where life is a recurring consequence. And if life is a recurring consequence in this solar system, the only solar system we have examined with any meaningful biological attention, then the numbers become staggering. There are an estimated 2 trillion galaxies in the observable universe. Our galaxy alone contains somewhere between 100 billion and 400 billion stars. Conservative estimates suggest that the majority of those stars host planetary systems, that a significant fraction of those systems contain rocky bodies, that a meaningful percentage of those bodies exist in conditions where liquid water is plausible, not just in the traditional habitable zone around a star, but in the expanded Europa revised definition of habitability that includes any body with tidal heating, internal chemistry, and liquid water, regardless of distance from its sun. The number of potential habitable environments in the observable universe, under the revised definition that Europa has forced upon us, is not millions. It is not billions. It approaches numbers for which human language has no intuitive referent. Quantities so large that they cease to function as numbers in any meaningful cognitive sense, and become instead philosophical statements about the nature of the universe itself. And if life is convergent, if it rises wherever conditions permit rather than requiring a singular, improbable miracle, then those environments are not merely potential. They are probable. They are, statistically, almost certainly inhabited. And we have heard nothing. This is the other silence, the one that operates at a completely different scale from the institutional silence surrounding Europa's exploration, but that is connected to it by the same thread of unanswered questions and unresolved implications, the Fermi paradox. If the universe is as full of life as the logic of a second Genesis would suggest, where is everyone? Why has no signal reached us? No electromagnetic transmission, no engineered artifact, no unambiguous evidence of technological civilization anywhere in the observable universe, despite decades of systematic searching. The silence from the cosmos is as profound, in its own way, as the plumes rising from Europa's southern pole. Both silences demand explanation. Both silences resist easy answers. One possible resolution, not the only one, not necessarily the correct one, but one that scientists and philosophers take seriously, is that life in the universe is abundant, but intelligence is not. That the step from microbial chemistry to complex multicellular organisms is extraordinarily difficult. That the step from complexity to technological civilization is rarer still. That the universe may be teeming with the equivalent of Europa's hypothetical microbes. Persistent, chemically inventive, biologically successful on their own terms, and almost entirely empty of anything that builds telescopes or sends signals or asks questions about the nature of its own existence. In this scenario, we are not alone, but we may be, in the only sense that produces neighbors capable of conversation. Profoundly, incomprehensibly, unutterably isolated. Life everywhere, loneliness absolute. And the answer to whether that scenario is true whether life is common and intelligence is the miracle rather than life itself, may be sitting in the dark water of a moon we have been photographing for 40 years, never truly reached. Europa does not merely ask whether we are alone. Europa asks what kind of alone we are, and that distinction between a universe barren of life and a universe full of life, but empty of minds, is perhaps the most consequential question a conscious species has ever been positioned to answer. We are positioned to answer it. We have not yet chosen to. We began with a moon. We end with a mirror, because that is what Europa has become. Not simply a scientific target, not simply an engineering challenge, not simply the most compelling case for extraterrestrial life in the history of planetary exploration. Europa has become the clearest mirror the universe has ever held up to our civilization. And what it reflects is not flattering in the way we might have hoped, and not devastating in the way we might have feared. It is simply true, and truth, in the end, is the only thing that matters when the question is this large. Consider where we stand at this precise moment in the history of our species. We are a civilization approximately 10,000 years removed from the agricultural revolution that made cities possible. We are roughly 500 years removed from the scientific revolution that made the systematic investigation of nature possible. We are less than 70 years removed from the first moment a human-built object escaped the gravitational pull of this planet and entered the wider solar system. 70 years. In the time scale of Europa's ocean. 4 billion years of dark, pressurized, chemically active water. 70 years is not even a rounding error. It is less than a single heartbeat in a lifespan that predates the existence of complex life on Earth. And yet, in those 70 years, we went from launching a metal sphere into low orbit to landing rovers on Mars, to flying a helicopter in the thin Martian atmosphere, to deploying a telescope that can observe the atmospheric composition of planets orbiting stars 40 light-years away, to sending a spacecraft, the Europa Clipper, on a 6-year journey to the moon that may harbor the most significant discovery in the history of science. The velocity of human capability is extraordinary. The question is whether the velocity of human wisdom is keeping pace. Because the discovery of life on Europa, whenever it comes, if it comes, in whatever form it arrives, will not be processed by the scientific community in isolation. It will land in a civilization that is simultaneously more connected and more fractured than at any previous point in recorded history. A civilization with the technological infrastructure to share a discovery of that magnitude with every human being on Earth within seconds. And the social and political infrastructure to immediately begin arguing about what it means, who it benefits, whether it can be trusted, and how it should be used. We are not well prepared for this. Not because we are foolish, not because we lack the intellectual capacity to integrate a paradigm shift of this scale, but because the institutions through which human civilizations process transformative information, religious institutions, educational systems, political structures, media ecosystems, were not designed for the pace at which scientific discovery now moves. They were designed for a slower world. A world where the distance between a discovery and its implications could be measured in generations, not news cycles. The Copernican revolution took more than a century to fully reshape the human cosmological self-understanding. The Darwinian revolution is still, in many communities, an ongoing negotiation between scientific consensus and cultural identity. These were not failures of intelligence. They were reflections of how deeply rooted our narratives about ourselves are. and how much structural work it takes to revise them at the civilizational level. The confirmation of extraterrestrial life will not have a century to settle. It will have a morning. And what we do with that morning, how we frame the discovery, what language we use to describe it, whose voices are elevated in the interpretation of its meaning, what political and economic interests immediately begin to orbit the announcement like moons around a new center of gravity, will determine not whether the discovery is true, but what the discovery does to us. This is not a peripheral concern. It is the central concern. Because the history of transformative human discoveries is not simply a history of expanding knowledge. It is a history of expanding knowledge weaponized, commercialized, misrepresented, and fought over by every interest that recognized its power before the broader civilization had time to understand its meaning. The discovery of the New World was also a discovery of extraordinary new life and extraordinary new civilizations. And what followed was not a celebration of the universe's richness, but a catastrophe of colonization that reduced that richness to rubble and slavery. This comparison is not made lightly. It is made because the pattern it reveals, discovery followed by exploitation before wisdom has time to intervene, is not a historical anomaly. It is a recurring feature of how our civilization responds to encounters with the new and the unknown. When the new and the unknown represent resources, leverage, or advantage to those who move fastest. Europa's ocean cannot be colonized in any meaningful near-term sense. The life it might contain, microbial, ancient, chemically extraordinary, cannot be enslaved or displaced. But it can be misunderstood. It can be minimized. It can be absorbed into existing narratives that diminish its significance in order to protect the comfort of those narratives. Or it can be met with the full weight of what it deserves. Wonder, rigor, humility, and a willingness to let the discovery be as large as it actually is. To resist the very human impulse to immediately reduce the incomprehensible to the manageable. To fit the universe into the frameworks we already possess, rather than building new frameworks to accommodate what the universe is actually showing us. There is a concept in the philosophy of science called the view from nowhere. The idea of an observation point so removed from human perspective, so stripped of cultural and personal bias, that it sees reality as it actually is, rather than as we have been conditioned to interpret it. No human being can fully occupy that position. But Europa, in its indifference, comes close. Europa does not care what we believe about our place in the universe. Europa does not adjust its chemistry to comfort our theology, or simplify our models, or validate our assumptions. Its ocean moves in the dark at the bottom of 20 kilometers of ancient ice, because physics requires it to, because Jupiter's gravity demands it, because the thermodynamics of tidal flexing produce heat, and heat melts water, and water flows regardless of whether anyone is watching. It has been doing this for 4 billion years without our permission and without our understanding. And it will continue to do so for billions of years after every trace of human civilization has been erased from the surface of this planet. Whether by our own choices or by the ordinary astronomical processes that will eventually expand the sun into a red giant and sterilize the inner solar system down to bare rock. We are, in the longest view, a temporary phenomenon, a brief, improbable, extraordinarily self-aware arrangement of atoms that emerged from the same stellar nucleosynthesis that produced Europa's ice and Jupiter's storms and the carbon in the plumes rising 200 kilometers above a frozen southern pole. We are made of the same material as the thing we are looking at, and that More than any single scientific finding, more than any spectral analysis or magnetometer reading or plume composition report, is perhaps the most profound truth that Europa's existence places in front of us. We are the universe looking at itself. We are the process by which this 4 billion-year-old ocean of chemical possibility has, on at least one world, become aware of its own existence and begun to ask whether it is replicated elsewhere. If there is life in that ocean, if something down there metabolizes and replicates and has been doing so since before the first animal drew breath on Earth, then the universe did not produce consciousness once. It produced it at least twice. And twice is not a coincidence. Twice is a pattern. A pattern suggests a principle. A principle suggests a universe not indifferent to complexity, but somehow, in the deep logic of its physical laws, inclined toward it. A universe where the emergence of organized, self-aware, question-asking matter is not an accident to be marveled at from a position of cosmic isolation, but an expectation. We do not yet know if that pattern exists. We do not yet know what lives, or does not live, in the dark water beneath Europa's ice. We know only that the question is real, that the evidence is serious, that the science is sound, and that somewhere between 500 million miles from where you are sitting right now, an ocean older than memory moves in total darkness, indifferent to our uncertainty, carrying whatever it carries, chemistry or life, molecules or organisms, the raw ingredients of possibility or the quiet, breathing proof that we have never been alone. And waiting, with the patience that only geological time can produce, for us to finally arrive. The question has been asked. The universe is not answering. It is waiting to see if we are brave enough to go and look.